Okay folks, we have revised the sine and cosine curves. Let's look at the vertical translation of the sine curve. Now remember what I warned you about? I said know your basic curves. So if we look at the mother curve for sine theta, which is this here, we know it starts at 0, it goes to 90 and 1, and then it will come back to 180, and then go to 270 and minus 1, and then return to 360, and there's a nice natural curve running between those points. But now, like we had for the line graph, if we do a vertical translation of the curve, then we are adding something to the mother curve. Let's just call it for now, let's say it's plus a for argument's sake. Okay, that can be a P, a Q, a D, whatever it is, but we're adding something to the sine curve. So it's the y value that's changing, it's the vertical values that are changing by this amount. Because this is a vertical shift, remember, if this a had anything to do with a theta, it would have been bracketed. So if I look at the one that I've got here on the side, it would mean that all the y values of all the points on the mother curve gets increased by a half. Okay, so that would mean this naught, if I take the naught value, because remember sine of naught is naught, and I add a half, the curve is going to be grounded at a half. So that in fact I'm going to make it black because that's the final point. Then sine of 90 was 1 plus a half gives me 1 and a half. Okay, the sine of 180, the y value is 0, I add a half, it lies at that point. Here at 270, this curve would have been at minus 1. Minus 1 plus a half lies at minus a half. And then it would have returned to a y value of 0 plus then the half. So the sine graph would look something in the region of that. The sine graph that has been translated vertically a half a unit. Okay, so I curve it carefully, and that's where my graph lies. Okay, in relation to the mother curve, remember the mother curve would have been the graph here in pencil. The whole mother curve has moved up a half a unit in the direction of y. So it's a vertical translation of a half upwards, this particular curve. Now you will see that it crosses the x-axis no longer at 0 and at 360, but at the points which are indicated over there. The y-axis, the y-intercept here is at minus a half. Now let's say, just for argument's sake, our domain that I was sketching on was from minus 180 to 360. So we've got the positive side here. We now need to continue this curve in the negative direction. Okay, so we know it would have been, the mother curve again would have gone to 90 and minus 1. Then it would have gone to minus 180, then to 270 and 1, and then to 360. Now all of these points also move up 1. The y value is minus 1. Plus 1 gets you to minus a half. So the curve is going to go from the half to this minus a half and 90. Here at 180 it was 0. We add 1 half to that y value, and that's where my curve will eventually end up. Okay, so I curve it nicely. So over this domain, it runs from minus 180 to 360. It is the mother curve. Now let me just continue the mother curve on the negative side for you. The mother curve is still moving up a half a unit vertically. Okay, folks, that's not so difficult. While this grid is here, let's look at, let me just label this. Y is the sine of theta plus a half. Let's look at another one. Y is equal to 1 minus the sine of theta. Now there's two things that happen at that curve. Or let's make it, let's leave it 1 minus the sine of theta. There's two things that happened here. Our curve, first of all, became minus sine theta. Okay? In fact, let's make it a half, because my vertical lines are not reaching far enough. So let's just take it from the mother curve's perspective. Now remember, your mother curve was y is equal to the sine of theta. It has changed to y is equal to minus the sine of theta. Now if you put your mind back to the function work that you did, if f of theta becomes minus f of theta, then the graph reflected, the mother curve reflected in the x-axis. So I'm first going to do that change. I'm going to reflect the mother curve in the x-axis, meaning all the positive y values become a minus y value. The minuses become positives. So the graph is literally flipping in this horizontal axis. Naught I can't do anything to, but this point would lie over there. This point will stay on the x-axis. This point has jumped up to a positive over there, and then it grounds back here. Now we're staying on the same domain. Okay, so here we have the same point. This would have jumped up to 1, and then that cross point there would be where the curve would really initially lie. So we've reflected it now. We have now drawn or marked off the points that belongs to y equals minus the sine of theta. We now want to mark the plus a half. Okay, so here we still have to add the half now. Now that's a vertical translation. Means this graph is also going to go up a half a unit. Okay, so it will go up, it will start over there. This is the initial y-intercept. It has moved up 1. The point where the next cross is down here. That would have moved up 1. This cross point would move up another 1. And this, another half rather. And then the cross point over here would also move up a half to land at 1.5. And then this point where it will exit, which is a half, will have a half added, and this graph will exit at the point 1. So if I bring it down, remember this point also, the minus 180 point, this one moved over there, this cross point. Okay, so if I'm going to draw this one as a dotted curve. There we go. I curve through my transformed points to the turning point. I curve it back up there, and then I go to the turning point that lies up there, and then return to the point over there. Now folks, that here would be the graph of this y is equal to a half minus sine theta. Remember, how did I read it? I first of all saw the sine curve is the mother curve. What happened to the sine curve? It got a negative. So it was a reflection in the x-axis. After I've reflected that curve, I moved it up a half. So first reflect the mother curve and then move up a half a unit vertically. Okay, so there was two transformations to the mother curve. A reflection in the theta axis, on the x-axis, the horizontal axis, and then a translation of a half upwards. I hope that made sense for you.